Hey folks, my name is Andrew McPhee, the Solution Manager for Industrial Security here at Cisco. So I take care of our reference architectures, our CBDs, our design blueprints for securing industrial networks. We're going to talk today primarily on plant security and what we do with visibility, cyber vision, and how that feeds into a segmentation strategy. So let's get right in. And why are we having this conversation? Why is security so important? Most of what you will see in terms of the innovations that are happening within industrial networks, and again, we're going to focus on plants for now, is AI. AI is the biggest buzzword that we have in recent times. And the reason why that is important to talk about is we done a report last year, State of Industrial Networking report. It's available on cisco.com. Anyone can view it. But about half of the respondents out of 1,000 people who responded said that AI was going to have the biggest impact, technology impact in the next 5 years. And that's a big deal for industrial, because what we're seeing is about 75% of enterprise generated data will be created in these industrial environments, in these plants, in these warehouses, in these utility networks, where organizations are viewing this data as critical to collect, which means that they're doing much more modernization of these networks. There's more virtual appliances going in, there's more compute coming in, the data center footprint is expanding, whether that's a centralized data center or just more compute within the local server rooms. The footprint for connectivity and compute is expanding hugely. And that means connectivity is increasing and the attack vector is increasing. And not only does AI make our jobs easier, I'm sure everyone that's listening to this call has used AI in some form and continues to use it, even if it's as simple as using it as a web browser. But it's also making the lives of the attackers easier. What we're facing in today's world is you no longer need to be a software engineer to hack a network. I can give an AI engine, a CVE, a vulnerability description, and it'll give me a working exploit within a few minutes. It knows how to create the code, it knows how to write Python, it knows how to understand attacks and threats and how to exploit them. I don't really need to know. I can just ask AI to do it and it'll do it for me. It might not do the perfect job, but it'll do a good enough job that it's going to cause some damage, and that's what we have to deal with. So as we do these connectivity projects, as we make sure that we're gaining an additional kind of footprint into these networks, we need to make sure we do it securely. It can't be a two-step approach. We can't say we're going to start with connectivity and then we're going to finish with security. You have to do connectivity and security at the same time. And this is the approach that Cisco takes to securing these networks. Cisco, there's not one single thing or one single product that Cisco will do to secure an OT network. If you want to know what Cisco does, it's these four things. The first thing we do is we help understand the OT security posture. What is actually happening in our network? What assets are connected? What vulnerabilities exist? What are those assets doing? What is the current risk posture that I have in the OT, so I can inform the decisions I'm going to make to secure it? One of those decisions we need to make is segmentation. We help customers limit that blast radius doing segmentation of OT networks. The problem with OT is, because it's been open for so long, is I just need to exploit one of those vulnerabilities on the OT and I have full access to the OT network. I'll do lateral movement, I can discover. There's nothing stopping me once I get into an OT, because it's fairly open once we get in there. We also need to control the risk from remote access. More and more folks are working from home. Even those that have gone back to office, they're doing 3-day weeks, and that's inclusive of the OT. I have a lot of friends who work in these industries, and they're doing 3-day weeks. And for the other 2 days, they're working on critical infrastructure from the comfort of their own homes using remote access tools. Those remote access tools, if they're not done correctly, can be exploited and becomes that initial entry into the OT, which then segmentation can be, or lack of segmentation can be exploited. So we've solutions across all these pillars, but what we don't want to do within the OT is keep all of that data in isolation, because the team that is doing the incident response to incident investigation, they're your security analysts. They live and work in your security operations center, and they're traditionally IT folks that have been tasked to help analyze and monitor the OT. So that data can't stay in the OT, it can't stay embedded within the tools within the OT network. We need to share and stream that telemetry up into that central SIM, and that's what Cisco does. It helps you do security end-to-end across both OT and IT and bring those teams working better together. So if you notice, there's no product names on this. So there's one of the key takeaways I want you to have is these are the capabilities that Cisco brings to the network. But let's talk about the products that actually make this happen. The first one, how do we get visibility into the network? If you've ever seen me in a presentation before, you probably are aware of this. But we simply just don't have enough visibility into OT networks. Most IT teams have some visibility. They do control some of the networking infrastructure for OT, whether that's up to layer 3 or down to layer 3 of the Purdue model, where they have some IT control switching, whether that's a utility network where they're managing that WAN network, or roadways where they can see up to the cabinet. Typically, we don't know what's beyond that. We don't know what these gray areas entail. We don't know what devices are plugged in, where the vendors, what kind of vendor profiles that we have, what vulnerabilities exist within our cabinets, within the utilities, within our plants. So cybervision simply just turns the lights on for these industries, if you want to use a marketing term for it. It lets you know what's down there. It gives you visibility into things that you just never knew existed. And as a security team, as an IT team, it just lets me know what it is that I'm dealing with. Because we may know that we're primarily a Rockwell shop, or primarily Siemens, or primarily Schneider Electric, whatever vendor that we use for the automation and control of our systems. But what about the other 20, 30% of assets that we didn't account for? What about the random off-the-shelf vendors that got there 5 years ago and no one documented that its existence? What about the system in our network that we thought was shut down but is still spewing traffic into the network? The firmware that's 8 years old and has a critical vulnerability that if anyone knew about it would be exploited by a 5-year-old. It's so easy to do. These are the things that cybervision is going to give you insights into. And it's that first step of securing a network, is to understand it. So primary use case of cybervision and the type of details that you get is that automated asset inventory. The first thing that you want to know is just what is connected to my network. And cybervision does this using deep packet inspection. So it's very different from an IT visibility tool in a way that it looks at the OT traffic to get access to that. So we're talking about being able to see the firmware versions, the model numbers, the rack slots if it's a PLC with a chassis. We get the detailed information of that asset. We get those detailed asset properties, and then we use that to find the vulnerabilities or to look up the vulnerability. The vulnerabilities come from a knowledge database, comes from our Talos threat intelligence, and we can say, based on all of these properties, here's the vulnerabilities that really do exist in your network. That firmware version is old enough to warrant that these vulnerabilities exist, and we can give you that with quite high confidence on that network. And once we know what an asset is, now we need to know what it's doing. So, okay, we know it's a Rockwell PLC, we know it's running whatever firmware version. What is it doing in my network? Does that look, is that unusual? Is it speaking to things it shouldn't, or is things speaking to it that shouldn't be speaking to it? Your most critical assets probably have very known and defined patterns, or there should be expected patterns that they have. If you see device types that shouldn't have this connectivity, well, we should flag it. Or if you're communicating to the external network like public internet, we should probably flag it. This is your way of saying, is there anything that's wrong in my network? It could be security, it could also be misconfiguration. We see that all of the time, where there's an expectation of how things communicate, but it never really meets expectations. So that's what the second thing cybervision does. What is the device, and then what is it? The vulnerabilities, as I mentioned, is key, because this is going to let you know what that attack surface looks like for your OT network. And vulnerabilities have a standard way to do severity scoring on them called CVSS. But cybervision does have a unique way of doing risk scoring for every vulnerability in the network, and that's using the Cisco security risk score. For those of you who have been around to understand what CANA is, it was an acquisition we made. It used to be called the CANA risk score. But it's a dynamic risk score on a vulnerability. So rather than looking at a static risk score that was defined on the point of that vulnerability being exposed, let's say there was a vulnerability in 2017, that score doesn't change. The score you got in 2017 is the score you still have today. With the Cisco security risk score, we look at more dynamic metrics, such as, has this vulnerability been exploited in the wild in recent years? Is there an exploit that's currently exists? Do we have any indications from web forums that this vulnerability is being discussed? Those are the type of things that we basically say, we know this vulnerability is relevant now, you should now, today you should take care of it. So it's a new way of prioritizing risk based on more like recent metrics versus just the vulnerability information itself. You can look at both, of course, but it just gives you a more dynamic priority based on real world conditions. And then the last thing I want to talk about, just purely from a visibility standpoint, is just alerts. One of the things that Cybervision does is it sees a lot of data, which can be quite overwhelming. And we don't want to overwhelm our users too much with just the pure volume of data that we have. And if this is not your first Cybervision webinar, these screens might look new. It's because we've updated Cybervision with a new UI, new user experience to basically surface up more alerts and eventually insights into all of that rich data that we have behind it. So rather than you have to try to find these things yourself, the alerts engine has been completely reworked. And we're going to be adding to this over time. So if we see a brand new vulnerability, let's say a device comes online, we didn't know enough about it the first time we saw it, a week later we get enough information and that has a severe alert and a severe vulnerability, we can alert you on. We see communications going to the internet, we'll alert you on that. It'll be these type of things that will let you know that there's something you should investigate now. That's what the alert engine is for. And then all of that contextual data that made it up can still be searched just as it was before within Cybervision. But what we're trying to really do is surface alerts to bring things to your immediate attention. And you get all of this embedded in a Cisco network. So I mentioned at the start of the call is, it's important that we do these things simultaneously. There's things that we can do on our legacy networks, which is tell me what exists based on kind of brownfield metrics. So I've inherited a network. It's never going to change. I just need to gain visibility into it without making any hardware changes. Cybervision can support that. We can do a span-based network. We can give hardware sensors. We can give you a Docker sensor. We can give you the bolt-on solution if you really require it. But building it in is really where you want to go. All of these new projects that we're undertaking, all of this kind of refresh opportunities that we have in the plant networks where we've had to introduce new equipment, like we're seeing a lot of vision cameras being introduced, which means more bandwidth required, which means a network infrastructure upgrade. Let's make sure that we embed security from the start. Anytime there's a brand new project in place that we need a new level of connectivity, security should be built in, not bolted on. But we can support both. Now, that's visibility. Visibility is great. We need to understand what is happening in our network, but a probably more important thing is how do you stop things from happening in the first place? And that's what segmentation gives us. How do we limit the blast radius of an attack using segmentation? And segmentation is a very overloaded term because I'm saying the word segmentation, and for those of you listening, you may have interpreted it differently based on your understanding of segmentation. And the first use case for segmentation, and some people are still here, is just IT/OT, the IT/OT boundary. You're segmenting the IT network from the OT network, or vice versa, the OT network from the IT, using a DMZ or firewall. So we have a bit too far there, the Cisco secure firewall, in order to make sure that the boundary between the IT and the OT is well protected. The often misunderstood use case, or the one that gets often overlooked, is the actual protection of the OT from the industrial data center. So I'm going to call it industrial data center. Some of you may call it a server room. But typically in a plant network, we have 5 levels at a Purdue with a DMZ in between 3 and 4. The industrial data center is a level 3 of the Purdue. So typically it's still a part of the OT network, which means it sits below the IT/OT firewall. If that room was to be compromised, because that's where most of the modern equipment is going, it has free reign of the OT. So we need to make sure that that is taken care of from a segmentation point of view. And in that case, I'd recommend another. It could be the same firewall. You could reroute back through the IT/OT. It could be a dedicated firewall. I'm not going to go through that on this call. I will reference a CVD later on that talks about those design choices. But the important thing here is that it's no longer just 2 macro zones in your OT. It's not IT and OT, it's IT/OT in your compute infrastructure. It's a new macro zone you need to take care of when doing segmentation. And then what most of you probably thought of when I said the word segmentation is probably this one. How do we prevent lateral movement within the control network itself? This is one that we typically stay away from firewalls from because it's so granular that to deploy this using firewalls, you're talking about hundreds of firewalls. This one we embed in the switches itself using identity services engines. So there's the kind of 3 called large buckets of segmentation. If you've not done any firewalling up to this point, we recommend doing firewalls. If you're ready to take that step into kind of true OT segmentation, where you're down in the process level doing segmentation, we recommend embedding that in the switches. But again, security built in, not bolted on. The same switches that gave you that connectivity in the first place will be the same switch that gives you visibility, and now the same switch that gives you segmentation. And segmentation is a journey. Not everyone will be ready to take that leap into micro-segmentation. And not everyone's ready to do access control straight away. And everyone wants to do segmentation. We want to put control in the network. But we can't just jump into pushing policies because we're going to cause our own downtime. And often the reason why we don't have segmentation is because we just don't have that starting point. We don't have that reference of how to implement it. So this is how we recommend go about it. And that is to start with something called virtual segmentation. Virtual segmentation is a simple concept. It is taking your visibility tool and virtually segmenting the network and watching for those deviations or watching what communications happen across these zones. So I'll show you how that works in CyberVision. But if you can collect all of the assets in production line 1 and monitor what they're doing, and you can collect all the assets in production line 2 and monitor what they're doing, you can simply visualize and react to any communication between production line 1 and production line 2. And if there's a violation of policy, you can take a reactive approach. But what virtual segmentation does, it allows you to plan your segmentation strategy. It allows you to understand what are the relationships I have across the zones in my network, and then make an informed decision of how I'm going to tackle the actual implementation of this policy. And when you do implement this policy, I know microsegmentation is always a goal, but we can't start there. Just because we have virtual segmentation in place doesn't mean I can just start doing microsegmentation everywhere. It doesn't really work like that. It's quite difficult to jump right into microsegmentation. So what it's telling you to do is start with macro, and macro may be like, your buildings. If you're a plant and you got, say, 5 or 6 different buildings, you might say, I'm going to make sure from building to building, I'm secure. And then later on, I'm going to go to building 1, and I'm going to start a microsegmentation project. And then I'm going to go to building 2 and start a microsegmentation project. Divide your network down into chunks, determine what your most important chunks are, start with macro, move down to micro. And the starting point of virtual segmentation comes from CyberVision. CyberVision, being your automated asset inventory tool, is where you're going to group all of these assets. You're going to see what's part of your energy systems. You're going to see what's part of your packing zone. You're going to see what's part of the paint shop, assembly shop, the conveyance system. All of these different parts of the network that should be part of their own little functional bucket. You can create those buckets of assets in CyberVision and then watch what those relationships are. Is there any communication between my production lines? Is there any communication between the engineering workstations that I have that should be dedicated to line 1 to other systems in the network? That's what CyberVision can help you, but you can visualize it using the zones and conduits method. And the zones and conduits comes from an industry standard, ISE 62443, probably the most widely accepted way of doing segmentation in this industry. Comes from the standard where we don't do segmentation at an asset level, but we do it at a zone level, and that's what CyberVision is helping us visualize. And once we do all of that work within CyberVision, it doesn't stay in its isolated bubble. It's sharing it across the Cisco ecosystem to be able to make policy decisions. So if you're at the point in your journey where firewalls is the first thing that you got to do in your network, we will share this information with our Cisco Secure Firewall so you can start doing visibility-driven firewall segmentation. If you're at the point that you can start implementing things on the switch level, even if it's at the kind of catalyst layer that sits just above the process zones, we can start implementing to identity services engine. Again, visibility-driven segmentation directly back into the switches. And when you're ready, you might start at the distribution layer with Catalyst and then slowly move down further and further, and suddenly all of your access switches start becoming enforcement points. Again, it doesn't have to be a one-shot journey. You can roll it out in phases. And if you're still just taking a reactive approach and you just want to look at what Cybervision is doing, but then take actions on the fly, that Cisco XDR integration is what allows you to do that. You have a whole workflow and automation engine that if you wanted to call playbooks based on the data that you're seeing, you can also do that in Cisco XDR. But the key part of this is you want the visibility to drive your segmentation, and that's what Cybervision and these integration points are enabling for you. I want to talk just a little bit about, the capabilities of the platforms that I just mentioned, because a lot of the times I get asked the question about the Cisco Secure Firewall and say, well, that's not an OT firewall, or one SKU that's an OT firewall. The software within the Cisco Secure Firewall is consistent across the board. It doesn't matter if you have a virtual firewall or one of our physical form factor firewalls. The virtual or the software that powers our firewall is consistent, and it is OT aware. So the firewall itself is powered by the Snort engine, and Snort is aware of OT protocols. It knows how to parse them. We can create custom Snort rules based on them. And the firewall itself has kind of two key functions for OT protocols. One, we can do deep packet inspection on those protocols to do prevention of function codes within the protocol itself. So if you ever hear of a use case where we need a SCADA system to have read-only access to things on the plant floor, the firewall has you covered. We can put a firewall in front of that industrial data center, in front of that server room, allow these vendors to put their data collectors virtualized in a UCS, and then give them read-only access to the most critical assets that we have. The firewall can do that for you. We also have hundreds of SCADA signatures dedicated to the SCADA networks, including zero-day attacks. If you ever go into the firewall and see this thing called a truffle hunter rule, it's a compiled rule. We don't even tell you what that signature means because it hasn't been announced yet. We have protections in place for things that haven't even hit the public because the Talos threat intelligence team is so big that they can get these signatures and they have these connections, or they do the threat research themselves to be able to protect you from things that haven't even been announced yet. And all of that is embedded within the Cisco Secure Firewall and very OT application network. TrustSec, on the other hand, is how we then go and do the more micro segmentation. So once you build those firewall boundaries, once you use that firewall for your OT networks, how are we going to do that kind of hybrid approach of I have some macro, I want to do some micro. You don't have to do full micro segmentation to do micro segmentation. And I want to tell you what we mean by that. Segmentation is a very basic thing, really, on the surface of it at least. All we say is we do authentication, which is who are you? And then we do authentication, which is what can you do? That's all segmentation is. If you tell me who you are, I can tell you what you can do. But there's two statements I want to make. The first one is I'm an OT device in the assembly workshop. I'm an OT device in the welding workshop. Nothing in that statement told you what device type it was. Could be a PLC, could be a HMI, could be a workstation. It doesn't really matter. I'm an assembly workshop device. I'm a welding workshop device. We can give policy based on physical location. And that is completely valid in terms of ISE 62443. It's completely valid in terms of NIST Zero Trust. Physical location for OT means something. If you have machines bolted to a floor, connected to the switch, and that's going to be the same connection we have for the next 10 years, you can probably say with a lot of confidence what that device is, because it's not going to change. So we can statically define it. We can say the assembly workshop has these privileges. And then on top of that, within the same policy set, we can layer on microsegmentation to say these 4 or 5 devices in the zone, they don't follow the policies of a typical assembly workshop device. They need more privileges. So we'll profile of those and we'll give them elevated privileges. And that's what we mean about the hybrid approach. That it's not microsegmentation across your tens of thousands of assets or 1,000 different device types. It is purpose-built policies based on use cases. And people have made this mistake before, where they take an approach where they say device type is how I want to do segmentation. But if you go to an OT network and you look at device types, you have vision cameras and barcode scanners and drivers and HMIs, RFID modules and torque tools, process PCs. You can go all day listing the different device types, and they're just the ones you know. They're not even the ones that you haven't even accounted for yet. And the question I always ask is, should the HMI in cell 1 communicate with the PLC in cell 2? And the answer is no. So we can never create a policy based on device type alone, because I can't say all of the HMIs can speak to all of the PLCs, because that is not how plants work. But yet they are the examples that you may see from some product demos, and it's just not representative of reality. And this is why we get stuck in segmentation, because we try to oversimplify demos and then you try to repeat it and it just doesn't work. What we do is we build security groups based on function. And that's why the virtual segmentation part is so important, because you're going to create your function groups, your security groups, based on use cases, based on functions. These are my cell area zone devices. This is my paint shop. This is my body shop. This is my interlocking PLC. These are my SCADA workstations for that zone, etc. The context of what that device type is matters, not so much the actual device type itself. And if you go down the path of doing segmentation this way, you'll get so much further along than you would if you started on the left-hand side. And all of this can be found in a Cisco validated design. So Industrial Security Design Guide 3.1. It's on our website. If you look at the Cisco CVDs, where we walk through the entire journey. So I only talked about visibility and segmentation today. There's only so much I can do within 30 minutes. But it talks about how we adopt that 62443 zones and conduits model and segment the OT network, both with firewalls, both with ISE, where to use one of the other, the design considerations, the architectural options we have is all in there. So please take a look at that. And we also talk about remote access. I didn't get into Cisco secure equipment access and how we solve the remote access problem. And we also have a chapter there on Splunk, how we tie this all together into a single platform. But yeah, with that, that's going to be the end of this session. This architecture is called Industrial Threat Defense. And hope to see you all soon.
Andrew, we did get one question. I think you did answer it on micro segmentation, whether it is only software defined or if there's another approach. I think you did answer it with the virtual segmentation approach, but maybe just to emphasize that micro segmentation capability in cybervision.
Yeah, it's essentially it's the sharing of information with ISE is what really enables micro segmentation. Exactly. So cybervision is the virtual segmentation part of the journey, but all of the context we share with ISE is what enables micro segmentation.
Perfect. That was all the questions we had. I see we do have a Slido up there as well, so folks, please take some time and fill that out. Thank you very much.
Yes, absolutely. Thanks so much, Andrew. Thanks, John. So yeah, please go ahead and answer that Slido poll at your earliest convenience and scan that QR code for some upcoming Industrial Insider sessions. So we hope to see you there. And with that, thank you so much for attending today's webinar. The recording will be made available and we'll keep you informed of upcoming sessions. Thank you so much.